Good morning friends. As you are aware, in previous session we were discussing about one of the important areas of project management, and that was cost management, and we have seen different processes of cost management. We have seen what is cost plan management, what is cost estimation, cost budgeting and cost controlling. It is important for an organization to save on cost, because there is saying that a penny saved is a penny earned. So, if you save on cost, then you would be in fact putting much less efforts rather than putting efforts in increasing sales. So, rather than increasing efforts on increasing sales, you just put more and more efforts on decreasing cost or controlling cost, because at the end of the day, if you see, then your profit would be more if you save on cost, right. So, it is an important area, and the management of cost in many ways reflects the project organization strategic goals, mission statement and business plan. So, you should control cost very carefully. We have already talked about what are different types of costs when we were talking about crashing of networks, and we have broadly classified them as direct and indirect cost. Apart from this, we have also seen that whenever you talk about cost of a product or a project, then mainly you can classify them as direct labor, direct material, direct expenses, and indirect labor, indirect material, indirect expenses, right. So, you can have different ways of classifying costs. These are also some of the sources of costs, though we have already seen labor and material. So, apart from these two sources, you have got contractors, equipment and facilities which you would be using to carry out your project, travel, and there are many more. There are several costs, right. Let us look at some other classifications. So, we have already seen direct and indirect, right. Let us look at one more classification. It is recurring and non-recurring cost. Recurring means which occurs after every month or after every 15 days or after every year, right. So, those costs are called recurring costs, right. And then you have got non-recurring costs. So, those charges which you generally incur only once, at the beginning of the project or at the end of the project, right. So, non-recurring costs do not reoccur, right. Then you can also classify costs as fixed cost versus variable cost. When I say fixed cost means, for example, in case of project management, when you are leasing a capital equipment or other project hardware, the leasing price is likely not to go up or down with the amount of usage, right. So, if you have taken an equipment on lease, let us say for a month, now it is up to you for how many hours per day you want to use or how many days in a month you want to use, right. Even if you do not use that equipment, you will have to pay lease amount, right. So, that amount remains fixed, right. Then you have got variable cost. Variable cost are those costs which increases with the quantity, right. In fact, this is one more example here, metal cutting operations. So, if you let us say cut more and more metal, then you will have to incur more and more cost, right. So, variable costs are those costs which vary with the output, okay. Then you have got normal cost and expedited cost. Those costs which occur in regular manner, they are called normal cost. But when you want to do some activity before its time, then you need to put some more resources and you need to expedite things. So, the cost which you incur in expediting things, those costs come under expedited costs, right. Let us look at this table. Now, in this table you have got different costs, you have got direct labor cost, you have got building lease, you have got expedite costs and material costs, right. So, these are different costs and these are different categories, right. So, you have got let us say direct and indirect, you can classify them on the basis of frequency. So, recurring and non-recurring, whether it is fixed or variable, and normal and expedited, right. So, this is based on schedule, this is based on adjustment, these two are based on frequency, and direct and indirect costs are based on type of cost, right. So, if I ask you direct labor cost is what? Is it direct type or indirect type? It's very simple, right. Direct labor cost is direct type, right. Is this recurring or non-recurring? Labor cost is recurring cost or non-recurring cost? It's a recurring cost, right. You will have to pay to workers every month, right. Is it fixed or variable? It is, okay. Let us look at this. Is it normal or expedited? Of course, it is not expedited, so it is normal, right. So, you just click on in all these sales of this particular row as far as this cost is concerned. What about building lease? Is this direct or indirect? What about recurring and non-recurring? Just think for a minute and give me answer. Let us look at expedited cost. So, of course, this would be right here, right. So, expedited cost. So, expedite cost is not normal, right, that is for sure, right. What about fixed and variability? Is it fixed or variable cost? So, you should be able to identify these costs into different classes, right. You should identify them and put into different classes. This is the answer. So, direct labor cost is recurring cost, as I said, it is fixed and it is also normal, right. As far as building lease is concerned, it is indirect cost, right. It is recurring, it is fixed but normal. Of course, expedite cost, direct cost, it is a non-recurring type, right, because you will be expediting project just once, right. Then it is variable and it is expedited cost. Material cost is direct cost plus it is also recurring, it is variable and it is normal, right. So, you should be able to identify cost first and you should be able to put it into appropriate classification. Okay. Let us look at something called learning curves in cost estimation. This is another important point. When I say learning curve, I am trying to say whenever you do some work for the first time, it takes a lot of cost and it takes a lot of time because you are doing it for the first time. When you do it second time, the time will reduce and cost will also reduce. If you do it third time, then time will further reduce and cost will further reduce, right. So, this is known as learning curve or learning effect, right. So, let us take an example. The time necessary to code a particular software routine is estimated at 20 hours for the first time, right. When you do the coding of the same software second time, it requires only 15 hours. So, we will say that the learning curve is 75% or learning ratio is 75%, right. We can apply that figure to estimate cost of additional coding iterations. In fact, we can not only know what would be the cost next time, but we can also know how much time it would be taking when we go for this coding of software third time, right, and so on, right. So, when the output is doubled from the first two routines to the required 4, the time needed to complete the exercise is now estimated to take 11.25 hours. So, whatever is the learning ratio here, you just multiply it by how much time it was taking second time, right. So, it is 0.75 into 15 hours. So, this is 11.25 hours. Next time what it would be, because you know learning ratio it is 0.75. So, just multiply 11.25 and 0.75, you will get the time for next time when you are coding it, right. So, this is known as learning curve, right. So, there is a relationship between time and cost estimate, and that relationship follows a definite formula, which is the time required to produce 1 unit of output and is represented as this, right. So, Yx is equal to A into x to the power b. So, where Yx is what? Time required for x unit of output. Yx is time required for x unit of output, and A is the time required for the initial unit of output, means the time which you have taken to carry out an activity for the first time, right, that is A. X is the number of units to be produced, how many units you want to produce, right, and B is the learning curve, which is the ratio of log decimal learning rate and log 2, right. So, let us look at an example and we will try to find out what is the value of A, what is the time required for the initial unit of output. So, let us take this example. There is a worker who has to do 15 activities, let us say fitting, riveting, squaring, let us say welding, soldering and so on, right. So, 15 such activities are to be done by that worker. Also assume that the time estimated to perform the last iteration steady state is 1 hour. So, we have observed that the time he took in a steady state is 1 hour. Now, we also know from the past experience that the learning rate of activity is 0.6 or 60%. Now, we want to calculate how much time he will take to carry out the activity for the first time, or how much time he would have taken to complete that activity for the first time. So, we want to determine value of A, and what is A? Time required for the initial unit of output. So, can you solve this question? Just take some time and try to solve this question. Okay, so first of all you should identify what information is there in the question, right. So, we know learning rate, isn't it? We know the steady state time, right, and we know how many units are to be produced, right. So, if you look at first of all in this formula, try to find out value of B, the slope of the learning curve. So, this log decimal learning rate and log 2, right. In fact, you have to calculate the natural log, right, not just simple log. So, B value is what? It is this, it is 0.60 divided by this. So, you have to take natural log of this, you will get minus 0.5108 divided by 0.69, and this value of B is minus 0.737, right. Now, you need to calculate A, and you have been given Yx, right. You have been given time required for x unit of output, right. So, this is 1 is equal to A, which is unknown, this is x, right. What is x? X is number of units to be produced. So, x to the power b, which is minus 0.737. So, a value of A is 7.358 hours. It means the worker would have taken to complete that activity for the first time 7.358 hours, right. So, this is an example on learning curve, right. So, you can have different types of learning curves. Sometimes you have 80% learning curve, sometimes you have 60% learning curve, sometimes you have 40% learning curve, and so on, right. So, the point is, whenever you do something for the first time, let us say if you have got cost 100 rupees and time 1 hour, when you do it second time, cost might come to let us say 50 rupees and time might come to 30 minutes, right. So, when you do it third time, then again the cost and time will come down in that ratio, right. So, this is an example on learning curve. Now, let me tell you some more points related to project budget. This is a very simple problem. So, there are different activities in a project. You have got survey, you have got design, you have got clearing of site, foundation, framing, plumbing and wiring. So, these are different direct costs, and you have also been given budget overheads for each of these costs, right. So, the total cost is, you can simply calculate by adding these two columns, right. So, this is your total cost column, right. Sample budget taking planned and actual activity cost. So, the same project, different activities. So, these are different planned costs and these are actual costs. So, we have to find out variance, right. So, variance is positive here, right. So, there is a saving of 250 rupees, right. There is no saving here. Yeah, you have just planned was this much, but actual is 3500. So, there is negative variance, right. Similarly, for all other activities, right. So, you can have at the end of the day, this is total variance which is positive, right. Let us look at example of time phased budgeting, though I have already talked about time phased budgeting. So, these are different activities. So, the budget for activity survey in January is 4,000, right. For design, budget in February is this, March is 3,000. So, total 8,000. So, similarly for plumbing and wiring, you have got 5,000, right. So, total by activity, right, the total budget by activity, right. Similarly, you have got monthly budget also for all the activities. For January, you have got 4,000, for February 9,000, for May 6,000, right. So, you can have a cumulative budget, right, like this. Okay. Now, let us move on to very important point which we are going to talk about. It is always said that you should complete the project in time, right. It is good to complete project in time, but there are people who would like to complete project before time. It is good to complete project before time if you are getting some, let us say, bonus from your client, right. Or if you are saving on resources, then it is good to complete project in time. But if you do not want to complete project in time, if you want to complete a project in time, if you do not want to complete it before time, then it is also fine. There is nothing wrong in completing project in time. It is good that you complete project before time, but nothing wrong if you complete project in time, right. Now, when you complete project in time, you can have different time estimates. We have already discussed those time estimates. Let us look at a situation where it is advisable not to follow the earliest start time in a project, but try to follow latest completion time or latest start time, right, so that you can save some money. I will tell you one very good example. So, let us take this network which has got 6 nodes and different activities. So, you have got duration of activity 1 to 2 hours, and for 5, 6 it is 3 hours, and you have been given other time durations, right. We want to find the cumulative cost by considering earliest start solution or earliest start time. So, find out what is earliest start at node 1. Earliest start is 0, earliest start at node 2 is 2, right. Earliest start at node 3 is 3. So, you just calculate earliest start and latest completion times at all these nodes, right. So, latest completion time at node number 6 is 17, right. So, you need to calculate TE in forward pass and TL in backward pass, right. Now, in this project you have also been given some cost related information. So, for activity 1 2, its duration is how much? 2 days, right. Its earliest start time is 0, right. You can start as early as 0 unit of time. So, for activity 1 2, its latest start time is 3. How did you get this 3? Activity 1 2, you can start as late as 3 unit of time. How did you get this? Any idea? We know that at node 2 TL is 5. TL is what? Latest completion time, right. So, whatever is your latest completion time, if you subtract the duration of the activity, you will get latest start time, is not it. So, this is 5 minus 2 is 3, very simple. Let us look at this for activity 2 4, or let us look at 1 3. Earliest start time of 1 3 is 0, right. Latest start would be what? Latest start would be TL is here, right, 3 minus its duration, so 0. Similarly, for activity let us look at this 4 6. What is earliest start of 4 6? 4 6 is here, right. So, earliest start is 7. 4 6, earliest start is 7, right. Latest start is what? The latest completion time minus duration of the activity, right. It will give you latest start time. So, 17 minus 10 is 7. So, this is latest start time. So, in this way you can calculate earliest start time and latest start time for all the activities, right. Now, let us look at the cost related information here. Activity 1 2 is taking a total cost of rupees 1200, right, and its duration is 2. It means cost per month is 600, right. So, all these durations are in months, right, not in days. So, for activity 1 2, the total cost is 1200 and its duration is 2 months. So, cost per month is 600, very simple. For activity 1 3, its duration is 3 months, cost is 900 for 3 months. So, cost per month is how much? 300, right. Similarly, for let us look at this 5 6, total duration is 3 days, total cost is 2100, cost per month is this divided by 3, right. Now, I know that I have to complete this project in 17 days, right. If I start all these activities at their earliest times, then I will complete this project in 17 days and I will be incurring this much cost, right, for each activity. So, I can you know, do the cumulative cost analysis here, right. So, let us look at what is the output or what is the outlay on very first day for this project. What you are doing on for activity 1 2, its duration is 2 days, right, and 2 months, right, its duration is 2 months. So, first month what is your expenditure? 600, right. So, just look at this. So, for activity 1 2, first month what is the expenditure? 600, right. Similarly, on in second month, what is the expenditure for activity 1-2? Also 600, right? What about activity 1-3? What is the expenditure for activity 1-3 on first day, or sorry, in first month? It is 300, right? Isn't it? Similarly, second month for activity 1-3, 300. For third month also 300, right? Now, if I want to know what is the cumulative expenditure for this particular project on first day, sorry, in first month, it would be this and this, 900, isn't it? Then what would be the total expenditure in second month for these two activities? Again 900, isn't it? And cumulative expenditure would be 900, then it is 1800, right? Similarly, you need to do it for all other activities, right? Let me show you how to do this, right? So, for activity 1-2, these are expenditures in this, not day, this month, right? It does not matter whether it is day, months or year, isn't it? So, the first 2 months, first month, this is output, or this is your cash outflow or expenditure, whatever you call it. This is for second month, right? This for activity 1-3. So, its duration is 3 days, right? So, on very first day, the total cumulative cost is 900, second month or second day it is 1800, and so on, right? If you look at activity 2-4, its cost is 0, so that is why this is 0, right? For activity 2-6, its earliest start is what? For activity 2-6, earliest start is 2 and its duration is 2. It means on third and fourth day for activity 2-6 is this, right? Yeah. So, its duration is 7 days, right? So, on third, fourth, fifth, sixth, seventh, eighth and ninth day, just see this, third, fourth, fifth, sixth, seventh, eighth and ninth day. So, this is your cost, right? So, if you take this cumulative cost, then this is cumulative cost, 22,000, 22,000 rupees, right? So, this is the total cost for 17 days if you consider earliest start time. Let us look at what will happen if you look at latest start time rather than earliest start time. So, we will take the same example and we will find out cumulative cost by considering latest start time. Latest start time means we will look at this particular column, not at this particular column. So, for activity 1-2, I know its duration is 2. For activity 1-2, its latest start time is 3, right? So, you just for activity 1-2 you just start from here, right, 5th day and 4th day, because you have to complete it by 5th day. So, why to start at first and second day, why to go for earliest start time, right? Why you are doing this on 5th and 4th day? Because you can save a cost, because here in this case the total cumulative cost in first month or on first day it is 300 only, while earlier it was just see 900. So, let us say if you are taking let us say loan every month, then you can save at least on interest, isn't it? So, it is sometimes good to schedule your activities according to latest start time rather than earliest start time. But keep in mind that when you go for second option, latest start time, then you do not have any slack or any float, right. You must have to complete those activities in latest completion time period, right. So, this is the case in this is the cumulative cost in case of latest start time. I will tell you how to do it for, let us say, activity 5-6, right. So, activity 5-6 is this, latest start time is 17, right. So, start from 17th day and move on 16th and 15th day, right, because its duration is 3. So, 17, 16 and 15th, just see for activity 5-6, activity 5-6, just see this is 17th day, 16th day and 15th day. Similarly, for 4-6, you just start from latest start time, right. So, at the end of the day, if you look at the total cumulative cost remains same, but what you can save is, you can save on at least on interest, because on first day the total outflow was 300, in this case, in earlier case it was 900. So, if you look at these two cost curves, cumulative cost curves by earliest start time and latest completion time, just see, if you go by earliest start time, then this is the cost outflow, right, or these are the expenditures, and if you go by latest start, this is the expenditure, right? But at the end of this, at the end of the day, you will have total cost as 22,000 in both the cases. So, with this let me stop here, and we will start a new area in next session. Thank you very much.